So welcome back students. So students, today we are going to take some exercises. Fine. And the things that we have learned before yesterday, I mean to say, that was binary to octal and binary to hexa. So this is like a binary to octal, how you're going to convert a binary number to octal. And the things that I've learned yesterday, that we have learned yesterday, that this is a binary number in front of you, and then if I have to convert this binary number to octal, what I'm supposed to do is I'm going to make the group of 3, right? And the reason for that is because an octal number system maximum takes 3 bits. So we're going to make the group of 3 bits together from the right hand side, just like this one. So that is 101, again 010, 101 and 101, right? So from the right hand side I made the groups of 3 bits, and then we are going to calculate what is 101. So 101, that is what? That is 5, since this is 4 and 1 5, right? 010, that is 2, again this is 5, again this is 5. So simple. So the conversion that we have done and the answer that we got is 5525. So that's the binary into octal. So you can understand, children, the conversion is pretty simple, binary to octal or octal to binary. Now if I have to convert this again into binary, the same thing I am going to follow. 5, I'm going to take that as 101, 2, I'm going to take that as 010, this again 101, 101, and then again I have this, again this back, I can again go back. So binary to octal or octal to binary, it is a very simple process. Let's take one more example, binary to octal. Again I'm going to create the group of 3 from the right hand side, right? And then we will have the numbers, that is 111, that is 7, 6, this is 6, right? 110, that is 6, and this is 1, and this is 4. So 4167. So that is the number that we got binary to octal. In case if there is any extra numbers that come, one single bit is been left out, in that case what you're supposed to do, just add 0 before that, 2 more zeros, and then you can calculate what exactly will be the octal number. And if there is 0, the 0 anyway it does not make any difference, so you can add 2 more zeros, so anyway that is going to be 0. So even if it is 04167, it is as good as 4167, right? Then binary to octal, okay, this is one example again I have taken. I am making a group of, again the 3 bits from the right hand side, and again you can see that it's 1 that is left. So what you are supposed to do, add 2 more zeros. So I added 2 more zeros and then I made the groups, right? This is the same number, I just added 2 more zeros over here, and then we calculate, this is 7, this is 6, this is 1, this is 4, and this is 1. So that's the number, binary to octal. So this is the exercise, children, for binary to octal, and then we will move on to binary to hexadecimal. So binary to hexadecimal, what we are going to do is we are going to make the group of 4 bits from the right hand side. So binary to hexadecimal, let's make a group of 4. This is the first group, which comes down to 5. This is the second group, again it comes down to 5, and this is 1011, it comes down to 11, isn't it? So 11, why 11? This is 8, so 1 2 4 and 8, 8 9 10 and 11, so 11. So this is the number 11 5 5. Now 5 will remain as it is, this is the symbol that we have, 5 will remain as it is, this 5 also remains as it is, but this 11 is what? This is B, right? That is the symbol for 11. After 9 hexadecimal number 0 to 9 comes what? A, and A is 10, and then 11 is what? B. So this I'm going to take it as 5, but 11 will be B. So what's the final answer? The final answer is B, 5, 5. Right? So let us take one more example, hexadecimal, binary to hexadecimal. So let us create the group of 4. That's the first group, second group, third group, and then again we are left with 1. So what I'm going to do, I'm going to add 3 zeros because I want a group of 4 bits, so I will add 3 zeros, and just I added this 3 0. Now if I create the groups, I can have the groups, right? So 0 1 0, so that is what? That is 5. This is also 5. This is 8 9 11, and this is what? 1. And then 5 will be taken as 5, this 5, but this 11 will be taken as B. If this would have been 12, then this would have become C. If this would have been 15, so this would have become F, right? And then this one as it is. So what is the final answer, children? The final answer is 1B 5 5. Fine, that's the answer. So that's the exercise we have done for binary to hexadecimal, and then again hexadecimal to binary. So if you have this number in exam, that is 1B55. So how you're going to convert this into hexadecimal? That is 5 is 0101, and you have to consider 4 bits and not 3 bits. If this would have been, anyway, octal number system cannot have B, but if it is 55 as octal number, then you would take only 3 bits. But this is a hexadecimal number, you're going to take 4 bits, right? 3 bits for octal, 4 bits for hexadecimal. So 5, so that is 0101, again 5 0101, and that would be the answer for 55, right? So binary to hexa and hexa to binary, it is pretty simple. Now let's move forward, that is octal to hexadecimal. Okay, do not focus on this I just left out the animation. So just let's focus only on this number, that is, this is an octal number 267. That's the octal number. Now this octal number I have to convert that into what? Into hexadecimal. How I'm going to do that? I'm going to first convert this octal number into binary. Okay, I'm going to convert the octal number into binary. So simple, 7. So that is what? That is 111. That is 7. 6 is what? 110, right? And 2 is what? 010, right? So 7 is 111, 6 is 110, 2 is 010. And then we are going to take this number together. So that's the same number, children. So 010, then 110, and 111. Now this is what we got after converting the octal number into binary. Fine. So first step is you have to convert the octal number into binary, and I've showed you the procedure how to do it. Then the final result, the result that we get, that is the binary result, this we are going to convert into hexa, just like what we did binary to hexa, simple. So we are going to convert a group of 4 because I want to convert this binary number into hexa. So this is first group, this is the second group, and then there is 1 0. So if there is 1 0, I have to add 3 more zeros, so this will be anyway 0. So I'm not adding that because it won't make much of a difference. So that is, this will stand as what? This will stand as 7. This will stand as B, that is 1011, right? And this will be any stand as 0. So 0B7, so it is as good as B7. So the answer, the final answer that we got is B7. and this is how you're going to convert a octal to hexadecimal, right? Also, the conversion of hexadecimal to octal is also pretty simple. Now I just going to take the same number, that is B7, and that's the hexadecimal. If I want to convert back to octal, so I should get the same number, that is 267. So let's find out B7. So if it is B7, so obviously just ignore this at this point. I'm going to take B and 7, and that is B. So 7, what is the hexadecimal for it? 0 1 1 1, 4-bit number, right? Earnable. And B will be 1011. So you can see that's the same number that I've taken. Okay, so I'm going to make a group of what? A group of 3 out here. Okay, and this is the second group. Okay, and this is the third group. See what happened over here. If I make a group of 3, so this is the first group, 111, right? So this is 111, then 0 1 1, that's the second group, and then left is 0 1. So this is only 2 bits, so I just added one more 0, so that became the third group. Okay, so this was the first group, 111, 0 1 1, that's the second group, and 0 1 was left, so I added 1 0, right? So then I created the groups. This is the binary representation, and then convert this into octal. So what is this? This is 7 1 1 0, that is 6, and 0 1 0, what is that? 267, isn't it? And that's the same number that we had it over here, that is 267. Once I convert that, it came to what? It came to B7, and again B7 I convert back to octal, it came down to 267. So children, this is how you're going to do the convergence. And now what I'm going to do is, I'm going to just create a PPT, I mean the PDF of this particular PPT, and I will share this with you, so you can have this as a reference. So let me go to export and PDF, and I'll just save it on my folder. Class 11 binary to octal will be the name, and we will see the final result. So you can have this PDF, children, for your studies. And possibly today or tomorrow I will give some exercise, so you can do this exercise in your fair copy in your notebook. I will give some more exercises tomorrow, and then children, see this is the PDF. Binary to octal second example, binary to octal third example, binary to octal one more example we have taken, and this was hexadecimal, right? Binary to hexadecimal, octal to hexadecimal, and you can see that's a very good PPT PDF file for you. Please refer to this PDF file. And then what is left, children, is the fractional values. How to deal with the fractional values, the decimal points. That is what we are going to learn from tomorrow. And after that, then we are going to deal with the one's complement and two's complement, and a few left out is that. But this is what this main chapter is. You are supposed to convert, the main part is the binary to decimal, binary to octal, binary to hexa, and the convergence that I've shown you till now. And till tomorrow, what I'm going to show you, that is the fractional values, how to deal with the fractional values. That is the main part. Means till now, till tomorrow, it will be the main part of the chapter. And then we have one's complements and two's complement. It's pretty simple, but the main part is this, what we are learning right now. Okay, and then let's see, I will just also give some exercise from some other book. We have also have the book Sumita Arora. This particular book, children, it is somewhere available in the Varanasi. I inquired myself, but it is of the previous year. Basically, it is not of the current year. So if you have the current year book of Sumita Arora, then you can go for that book. Otherwise, anyway, we have the book provided by the CBSE, and it is not going to really matter a lot. Okay, even if you refer this book, it is quite good. Other than this book, I'm going to give you a lot of notes, so do not worry. Okay, computer is much more about practical than theory. Yes, we require theory, we require certain terms to we have to understand it. Okay, something has to be in written form, right? But it is more of a practically, if you know it, if you understand the concept practically, then you can write it in your own words. So that's it, children. So this is the thing that I've told you today, and I'm going to post this PDF in the WhatsApp group. Please practice it, and then tomorrow we will deal with the fractional values. Okay, that's it, children. Bye for now.